Welcome to this SSRS Report Builder tutorial. In this video we're going to cover how to deal with multi-value parameters in stored procedures. We'll start the video with a quick reminder of how to use multi-value parameters with basic queries, and then how you can pass multiple values into a stored procedure and why that goes wrong when you do. We'll then explain a couple of techniques for splitting a string into separate values within your stored procedure, first of all using a built-in function that's available from SQL Server 2016 and later, and then how you can create your own custom user-defined function to do the same thing if you're working with an earlier version of SQL Server. So let's get started. Here's a basic example of the type of report we'll create in this video. The main table shows a list of films, and we can change which films get displayed by selecting from the two multi-value parameters at the top of the report. So whichever genres I select from this drop-down list, and whichever countries I select from this one, will affect the results when I click the View Report button. Now there's nothing really surprising about that. If you've watched earlier videos in this playlist, multi-value parameters are nothing new. The thing that's different about this report is that the data set which gives the results to this table is populated using a stored procedure, and there are a few slightly tricky things about passing multi-value parameters into a stored procedure and having those results interpreted correctly, but we'll explain how that works as we work through the video. If you would like to follow along, you'll need a copy of the SSRS Movies database, and just a quick reminder that you can learn how to install that using this video, and there's a link in that video's description that you can use to download the script file that you'll need. Assuming you've done that already, the first thing I'm going to do is head over to a blank report in Report Builder, and then add a data source to connect to that Movies database. I'll call my data source Movies, and then I'll use a connection that's embedded in the report, pointing to a Microsoft SQL Server, and then click the Build button to get some help with the connection string. I'll type in // to shortcut to the local host, and then the name of the instance of SQL Server I'm using, which is SQL 2017. I can then select my Movies database from the drop-down list here, click OK, and OK again to create my data source. To create the dataset, I'm going to start by using a basic query stored in this report, and then we'll convert that into a stored procedure later on. So I'm going to right-click on my Movies data source and choose Add Dataset. And I'm going to call this one Films. And then in the Query Designer, I'm going to select from a range of different tables. So from the Tables folder, I'll head to the Film table first, and I'll select the title and the release date. And then from the Country table, I'd like to select the country. And then from the Genre table, I'd like to select the genre. So I'd like to display all those results in the main table I display to the end user. I can click OK to create that basic dataset, and then click OK again. And then I'll display those results in a table in the report. I'll tidy up first by removing the page footer, and then removing the placeholder title text box. Right-click in the body of the report and choose to insert a table. And then I'll populate the columns with the fields I've selected from my dataset, so title, release date, country, and genre. I'll just change some column widths here as well to make sure that I can see everything clearly when I run the report. And then I want to make sure that I don't encounter the font rendering bug, so that when I run the report I actually see all the text in the table. You may have encountered this yourself. I've certainly encountered it in previous videos. If I select all of the cells in the table and then switch the default font to any other font and then back to the default, that should ensure I see all of the text when I run the report. A bit of very basic formatting. I'll format the release date in the date format, and then some background colours for the header row. And then I can run the report just to check that I'm seeing sensible results at this stage. And there we go. Next, I'd like to add a parameter to filter this set of results based on the film's genre. To do that, we can head back to the design view, and I can right-click on the Films dataset and choose Dataset Properties. I can then add a where clause to my query, so let's just zoom in so you can hopefully see that more clearly. At the end of the select statement, I'm going to say where, and then I'm going to reference the genre ID field. So I'm going to say film.genreid, and then because I want this to be a multi-value parameter, I'm going to use the in operator. And then in a set of round brackets, I'm going to pass in a reference to a new parameter name that I'm about to make up. So I'll type in an @ symbol. Let's call this one genre IDs. And then I can close the parentheses or the round brackets. And when I click OK, I'll generate a corresponding report parameter, also called genre IDs. I'm going to modify a couple of basic properties of this parameter. So I'm going to double click on it, and then I'm going to change its data type so that it's using an integer type. The genre ID column is an integer rather than a string, so change from text to integer. And I also want to allow multiple values. So at this point I can click OK, and then I can run the report. And if I click on the drop-down list, I can type in a list of individual genre IDs. It's difficult to know what numbers to type in it, but I'm going to go for the number 1, 2, and 3 inventively. And then when I click the View Report button, it will show me a list of films in the 3 genres: science fiction, which I believe is the number 3, drama the number 2, and then there should be some westerns in there as well, which is number 1 in my list. Multi-value parameters tend to work better when you provide a list of available values for your user to select from. So let's create another data set that will populate this list with the names of the genres, but store the genre IDs. We can head back to the design view, and then we can right-click on the movies data source and choose Add Data Set. I'll call this one Genre List, if I can spell that correctly. And then if we head to the Query Designer button, from the tables list, I'm going to pick the genre table and then select the genre ID and the genre. I'll click OK, and then I'm just going to add a quick order by clause as well, so that I can see my genres sorted alphabetically by genre name. So I can say order by genre. Once I've done that, I can click OK, and then head to the genre IDs parameter. I can head to the available values page, choose to get values from a query, select my genre list dataset, set the genre ID as the value field, and then the label, which is what the user will see, will be the genre. Again, this is not particularly surprising if you've followed the previous videos in this playlist. So if I run the report at this point, I can now select from a range of genre IDs. Let's select the same ones we saw earlier on. I'm going to go for westerns and dramas and science fiction. And then if I click the View Report button, we'll get the same list of values we saw when we just typed in the numbers 1, 2, and 3. Okay, now that we've got the basic part working, I'd like to convert my simple select statement in the dataset of this report into a stored procedure. So let's head back to the design view, and rather than recreating all the code for our query, let's right-click on the films dataset and choose Dataset Properties, and then I'm just going to copy all of the text from the query box to the clipboard and then click OK or cancel. It doesn't really matter. We then need to head over to SQL Server Management Studio. So I've got an open instance of Management Studio connected to my SQL 2017 instance, so the same instance that we connected to for our data source. And I've got the movies database selected here. I'm going to choose to create a new query and then give myself a couple of blank lines at the top of that query and then paste in all of the code I've just created. I'm going to add a couple of extra statements up at the top. I need to convert this into a stored procedure. Now, when you create a stored procedure, it's worthwhile ensuring that your stored procedure gets created in the database you want. One way to control that is to select the database you want to use from this drop-down list at the top left-hand corner. But it probably makes more sense to enforce that in your code. I'm going to say use movies and then go before we then write the code that will create the procedure itself. To create the procedure is fairly straightforward. We write a statement that says create proc, or you can also say procedure if you prefer, but I prefer the shorthand version, create proc. We can optionally say which schema this stored procedure will belong to, so I can say DBO, for example, followed by a full stop, and then state the name that I want to give to my stored procedure. I'm going to call mine films multi-value parameters. Bit of a long-winded name, but it's nice and obvious and descriptive. One more thing we need to do is to declare a parameter which can accept the correct data type for the column we're comparing it against. So we're referencing a parameter in the where clause here. It makes sense to copy that parameter name, and then below the create proc statement, we can say genre IDs and set the data type to the data type of the genre ID field. If I hover the mouse cursor over genre ID, you can see that its data type is an int. So I can say genre IDs int. I then simply need to say as, and then the code that will create this procedure is now correct. I'm just going to highlight the select statement from top to bottom, and then hit the tab key to indent it one space. I just prefer that layout personally. And then if I hit the execute button, that store procedure will be created. You can check that the procedure exists by expanding the movies database, finding the programmability folder, then the store procedures folder, and you should find that when you expand that for the first time, your new store procedure is sitting in that list. I've got another one there. This is the one that I was using for the test, or the example report I showed you at the start of the video. If you don't find your store procedure there, you may need to refresh the store procedures folder. So I can right click on the store procedures folder and choose to refresh it, and that will update it to ensure that it definitely does appear. Okay, now that we've created the procedure, let's go back to the report and use that to populate our dataset. So I'm going to go back to my report in Report Builder. I can right click on my films dataset and choose Dataset Properties. And then rather than using a text query, I'm going to choose to select a store procedure. And then from the drop-down list which appears, I can choose my film's multi-value parameters procedure. I can then click OK, and that will update the way that dataset is populated. At this point, we can run the report, and we can test it in a basic fashion. If we click on the drop-down list and select just a single genre, and we hit the View Report button, everything works perfectly. Well, apart from the fact that we've returned Twilight movies, but that was my fault, so let's get rid of those. What happens if we select more than one genre, however? This is where we start to encounter problems. If I select multiple genres and then click View Report, the report no longer works. We can see the error message by clicking the Details button here, and it's complaining about a conversion of data types from nvarchar to int. So I'm just going to click OK and then head back to the design view and then try to explain what's going on here. To help explain what's going on here, I'd like to use another tool in SQL Server Management Studio that can show us which store procedures have been executed and what values have been passed to them when we run our reports in Report Builder. So to do that, I'm going to head back to SQL Server Management Studio, and I'm going to head to the Tools menu and choose to open the SQL Server Profiler. When that launches, I'll need to connect to an instance of SQL Server, so I'm going to make sure that's the same one that holds my movies database and the store procedure we've just created. Click Connect, and then I need to configure what it is I want to trace when I start running the profiler. Now there's lots of information displayed by default by the SQL Server Profiler, so I'm going to go to the event selection and narrow this down somewhat. I don't really care about anything other than store procedures that have been executed. So this particular item here, RPC completed, remote procedure call completed. I'm just going to uncheck these other boxes. I don't really care about tracing those. And then I'm going to make sure that I include the text data of the remote procedure call as well. Having done that, I can also filter a particular column to make sure, or try to narrow down at least, to procedure calls made from a particular application. Now there's lots of background remote procedure calls running in SQL Server all the time, and if I want to avoid seeing a long list of extra procedures that I'm not interested in, I can apply a column filter to the application name column. So I've clicked column filters, I've got application name selected here, and then I can expand the like box, and the name of the application as it's listed in the SQL Server Profiler for Report Builder is more to do with the provider we're using to connect to SQL Server. So it's all about the data source connection type we've used. So I'm going to type in .net followed by a percentage symbol. So using a basic SQL Server wildcard. So the name of the application will begin with .net followed by any other bit of text. Okay, so having done that, I'm going to click OK, and then I'm going to click the Run button to start running my trace. So you can see now I've got a new window that shows me my trace being started. So now if I interact with Report Builder, if I head back here and run my report, and then if I choose a single item from the list, let's just choose, so let's just uncheck everything and then check, for example, Action and click View Report. So that one will work, and we can see that we've got all the action movies. If I switch back to SQL Server Profiler, you can see that I've completed a remote procedure call, and this is the statement that was executed. An exec statement, execute this store procedure and pass in the ID number 4 to the genre IDs parameter. So you can see that there is being passed in as an integer, as a whole number, so that's going to work. Let's head back to Report Builder, and this time let's choose multiple genres. Let's go for adventure and animation as well. we know this is going to fail. We get an error, and we can see that we've got this same error message about converting nvarchar to int data. So let's just click OK and then head back to SQL Server Profiler. So we can see we've got some more remote procedure calls. One that happened automatically to reset the connection, and then this one is the one we've executed when we click the View Reports button. You can see it's passed in not a single number and not even technically a list of different integers. It's passed in a single nvarchar string to a parameter whose data type must be an int. So that's why we're getting this error. Okay, so now we know what the problem is. Regardless of what the data type of the report parameter is, if you select multiple values from it when it's passed into a stored procedure, those multiple values are treated as one single continuous nvarchar string. So that means that our stored procedure needs to be able to accept an nvarchar value rather than just an int. So let's head back to SQL Server Management Studio, and we'll need to make some changes to our stored procedure to make this work. First of all, I need to change the word create to the word alter. I can't run this script again. If I click execute, it tells me there's already an object with that name in the database. So I don't want to create it again. I want to change the existing copy of that. So I can say alter rather than create. The red squiggly which appears there is just because the IntelliSense hasn't updated itself yet. It doesn't really matter, the code will still work, but if it bothers you, you can head to the Edit menu, choose IntelliSense, and then choose Refresh Local Cache, or use the keyboard shortcut Ctrl and Shift and R. And once you've selected that, after a couple of seconds, the red squiggly should disappear. There we go. And then you can execute this script as often as you like. I'm not obviously making any changes to it yet, but it is technically updating the definition of that procedure. Okay, so we know that we need to be able to accept an nvarchar value rather than an int for this parameter. So let's change the data type from int to nvarchar, and then let's specify how long the string should be. Let's arbitrarily put in 255. That'll be more than enough for the range of genres we can select. So at this point, if I click execute, it will update the definition of the procedure. And now I can pass a string into that parameter when I call this procedure. But I'm going to run into another problem, of course, as we'll see in just a moment. But just for the time being, let's head back to our report and let's select a different list of options and then click the View Report button and find that it does indeed fail again. But if you click the Details button to see the message, you'll see a subtle difference. It's still a problem with converting data types from nvarchar to int, but it actually shows us the range of values we're selecting this time. So actually a little bit further through the store procedure than we got last time. I'm just going to click OK and then head back to the design view. This time I'm going to go back to SQL Server Management Studio. The profiler is still running, by the way, and you can see the trace of the previous call, but that's not particularly informative at this point. But if I go back to SQL Server Management Studio, the problem here, of course, is that the value of the genre ID field in the underlying database hasn't changed. That's still an int. And what we're trying to do now is check if that integer value is in a single string 1, 2, 3, for example. The next step in solving the problem is to take this single comma-separated string and split it out into a list of individual numbers. Just to demonstrate how that's going to work, I'm going to copy this entire select statement from my stored procedure script, create a new query, and then paste all that code in to that new query page. So at the moment, what we want to achieve, let's imagine we selected the numbers 1, 2, and 3, Westerns, dramas, and science fiction films from our genre list. What I want to be able to do is compare those individual numbers as separate individual numbers. And if I can do that when I execute the query, it will work. Of course, the problem we have at the moment is that we don't have those separate individual numbers. We have one single continuous nvarchar string. So at this point, essentially the in operator is useless. We're not looking at the individual values. We're really just checking to see if the genre ID is equal to that single string, which of course it doesn't really need to be proved that this doesn't work. We've already established that that's not going to work, but that's our problem. So how can we split that string into individual values? I'm going to write a new select statement at the bottom of this query. I'm going to say select. I'm going to use the asterisk character to select everything, every column, from, but I'm not going to refer to a table. I'm going to use a function that was introduced in SQL Server 2016 called string split. If I open up some round brackets, you'll see there are two parameters for this function. One is the string containing all the values you want to extract, and the second is the separator character, which separates the individual items. You'll see this function returns a table, so it's a table valued function, which is why I'm using the select statement to return everything from it. So if I just copy that string from my query to there, and then provide the second argument to the string split function by saying these items are separated using comma characters. If I then close the round brackets, if I highlight and execute just that single select statement there, I'll see that it converts that comma separated string into a table containing those individual values. The column name generated by the string split function is called value, so rather than saying select star, I could say select value instead, and that would do the same thing. Now technically those values still aren't integers, those are substrings, they're still n-varchar characters. It won't really matter. SQL Server will be clever enough to work out an implicit type conversion, so it will be able to treat these individual strings as numbers when we compare them against the genre ID field. However, it's best to be technically correct about this sort of stuff, so let's add a cast around our value field to say cast as int, so that they will definitely be converted into integers, and then we can assign an alias to that, let's say as value again. Okay, so we're nearly there. What I'm now going to do is take this statement here and replace what we've previously had. So I'm going to change my where clause to say in, and then open up some round brackets, and then I can simply move this select statement inside those round brackets. So even though we're technically referring to a comma separated string here, this selection from the string split function will convert that into a list of values, and now the entire thing will work again. So I'm getting my science fiction films, my drama films, and hopefully somewhere down the list some Western films as well. Okay, so now let's update our store procedure with this new select statement that uses the string split function. I'm going to copy select cast value as int as value from string split all the way to the end of the first close round bracket there. I'm going to copy that, head back to the script which creates our store procedure or alters our store procedure, and then change where it says at genre IDs, I'm just going to paste in what I've just copied. I'm then going to modify where I've said n1, 2, 3 and replace that with a reference to my at genres parameter. So I can remove that, replace it with at genre IDs. Just to tidy things up a little bit to make it a little more readable, I'm going to split this across multiple lines. So there's my select statement. So I'm selecting the integer version of the values from the results of the string split function, splitting the genre ID comma separated string using the commas to identify the separator. Okay, so that's a little bit more complicated than ideally it would be, but if we execute this script now to update our store procedure, we can then head back to our report and we can run the report. We can select a range of options from this list. Let's just select them all, why not, and click the View Report button. And we'll see this time we do indeed return all the films regardless of which options we've selected. Bearing in mind that your trace is still running in the SQL Server Profiler, or at least mine still is, so we should be able to see now these extra traces that we've just been using, passing in either the full list of IDs or just that final one there, which was that shorter list. If you want to stop your trace, by the way, you can hit the stop button and then just close down the SQL Server Profiler. So if you're lucky enough to be using SQL Server 2016 or later, you can simply use the string split function to separate out your multi-value parameter selections into the individual values. But what if you're not that lucky? What if you're using an earlier version of SQL Server which doesn't have that function? Well, in that case, we've got a little bit more work to do, but not too much more work actually, and it's a bit of fun. We're going to create our own table-valued function to split a string into its separate component parts. Let's head back to SQL Server Management Studio. I appreciate this part of the video is getting more into SQL than Report Builder, but it's still, I think, useful information, so I'm going to include it in this video anyway. Let's create a new query, and at the top of that query I'm going to make sure that I say use movies to make sure that my function gets created in the correct database, and then go, and then we're going to say create function. So similar to create procedure, although we can't sadly abbreviate this to create func, so we must spell out the full word function. I'm then going to say that this is in the DBO schema, and then we can make up a name for our function. The built-in one is called string split, so let's be inventive and call ours split string. We then need to define a parameter, or at least one parameter. I'm going to define two parameters. So the string split function accepts the full string you want to split, and then the character which separates the individual entries. So let's replicate that functionality here. I'll open up some parentheses, and then on the next line, I'll call my first parameter at full string, and that's going to be nvarchar max, so we can pass in a huge string if we want to. And then the second parameter is going to be called at separator. I'll spell that correctly, separator. And then I'll call that one nvarchar, and that will be a single character, so nvarchar 1. I'll then close the extra set of round brackets for the parameter list. And then on the next line, for a function, we have to say what type of information the function returns. So for a table valued function, we need to say returns. Then we need to make up the name for a table variable. So I'm going to start with at, and I'm going to call this one t, inventively. The end user will never see the name of that table, so that doesn't really matter. At t will be fine. And then I can say that its type is a table, and then in some round brackets I can define any columns that that table will have. So I'm going to call my column value, which is the same as the column name in the built-in string split function, and I'll set its data type to match the data type of the full string. So that's nvarchar max. Close a couple of sets of round brackets for that. Then on the next line I can say as, and then I need to contain the definition of my function within a begin end block. Now technically there's only one more line I need to write in order to make this function valid, and that's the keyword return. So at this point my function definition is valid. I can pass in a full string and a separator character, and all I get back at this point is an empty table with no rows in it. Next, I'm going to declare a couple of variables that will help us to separate out the individual entries from the full string. So I'm going to say, first of all, declare at single string. So this will represent a single item in our list. And I'll set that to be nvarchar max again. So that could be the full length of the full string that we've passed in. I'm then going to declare a variable which will hold the position in the full string of the separator character that we're looking for. So I'm going to call this one separator, I'll spell that correctly eventually, separator position. I'm going to set that data type to be an int, so it's just a number which holds the position of a character in a string. I'm also now going to initialize that variable by calculating the position of the first separator character in the full string. So to do that I'll say equals, and then I'm going to use the char index function. So the char index function allows you to search for one string within another string. So the thing I'm going to look for will be my separator parameter, so I'll say at separator. I'm going to look for that within my at full string parameter. Okay, so that's the starting point done. I've got a couple of useful values that I can now use to return the rest of the results. The next set of instructions I'm going to write need to be executed multiple times. So at this point I'm going to begin a loop structure in the function that will continue repeating instructions until some kind of condition has been met. So to create a conditional loop in SQL, you can begin with the word while, And then on that same line, we need to write some kind of logical test to determine when the loop structure will end. The condition I'm going to use is whether or not I have found the next separator character I'm looking for. So when you use the char index function, it looks for the position of the separator character in the full string. So imagine my string was 1, 2, 3, for example. Oops, sorry. Let me type that in again. There we go. So if I looked for a comma in that string, the first value that the char index function will return is the number 2, because the first comma is the second character in that string. If that list didn't have any commas in it at all, then the char index function returns 0. So I know that as long as the value of the char index function is greater than 0, I have successfully found a comma character or a separator character. So my while condition is going to be while at separator position is greater than 0. I'm then going to wrap up the instructions for my while loop in another begin end block, and then I can work out what it is I need to do inside that loop. The first thing I want to do inside the loop is strip off any characters from the full string that appear to the left of the first separator character that I found. And I'm going to store that value in the single string variable. So I'm going to say set at single string equals, then I'm going to use the left function, which returns characters from the left of a string of text. And I'm going to say the expression I'm stripping my characters from is the full string, so I can say at full string. And the number of characters I want to get is 1 less than the separator position. So I can say at separator position, I'll spell that correctly, -1. So just to, again, demonstrate what that means, if I typed in a string, let's say a, b, c, if I've looked for the position of the first comma, that returns the number 2. So separator position is the number 2. And then I've subtracted 1 from that. So the result is 1, of course. Even I can do that mental arithmetic. And then I've said get 1 character from the left of the full string. So the result of that statement will just be the letter A. So what I can do now is insert that single string into my table variable to start building up my list. So to do that, I can say insert into at t. There's only one column to populate, so I don't need to write out a column list. I can just go straight to the values section and then in a set of round brackets say at single string. Okay, so that's the starting point of building up my list of separated values. Next, I want to modify what bit of text is held in the full string variable by getting rid of any characters up to and including the first separator character. So to do that, I'm going to say set at full string equal to, and then I'm going to use the substring function. So I've got 3 options or 3 parameters to fill in for the substring function. The first is the bit of text I'm getting my substring from. So that's also going to be at full string. The second is the starting position for the substring I want to return, and that I want to be 1 character after the separator position. So let me just copy and paste that bit, separator position, and then rather than -1, we'll say +1. We can then type in another comma and say what length of string do we want to return? Well, I just want to return everything all the way up to the end of the current full string. So a quick simple way to ensure that is to calculate the length of the full string using the len function. So I can say len at full string. Then I can close 2 sets of round brackets to finish that line. So again, if we think about that, that sample string, that imaginary string, a, b, c, my separator position is currently the number 2. That was the position of the first comma in that list. So I've added 1 to that. So I've said begin at essentially character number 3, and then return all the characters all the way up to the end of the string. So the end result will basically be the deletion of a comma. So I'm left with b, c. The final thing I need to do inside the loop is recalculate the position of the separator character. So I've modified the full string. I want to now update this to find the next separator position. So to do that is fairly straightforward. I can say set at separator position, and I can make that equal to the same expression I used to assign a value to that in the first place. So chart index at separator in the full string. So I'll calculate the next position and then go back round to the top of this loop, check that I have actually found the next separator position so that I've got a value of greater than 0, and if so, repeat that process to insert the next item in the list. And that loop will continue going around until the remainder of my string has no more separator characters in it. So there's one more thing we'll also need to do. If we imagine we'd reached the end of this loop, we have a string that just has the letter C in it, and we set the separator position by looking for a comma in that single character string. Then the separator position becomes 0, so it goes back to the top of the loop. It establishes that the separator position is not greater than 0, so it wouldn't insert that final character, that final item in the list. So just to ensure that our final list item gets inserted into our table, we're going to say insert into at t. I'll just copy that line. And then rather than single string, we can say whatever remains in the full string. We know that we'll have stripped off everything else prior to the last separator character, so inserting that will guarantee that we'll get the full list inserted into the table. Okay, so there's the full function created. Let's execute this script to create it. So I can click the execute button to hopefully commands completed successfully. And then if I look in my programmability folder in the movies database, head over to the functions folder in there, and then look in the table valued functions folder, I should find my split string function is sitting there. Again, if it doesn't appear by default, you can right click on the table valued functions folder and choose to refresh it to update that list. I'd also like to give this function a quick test, so I'm just going to copy the function name and then create a new query window. And here I'm going to say, let's say select value from. So I know that I've called the column from this table value, so value from, and then I'm going to paste in my function name, and then I'm going to open up some round brackets, and I'm just going to type in that manually comma separated list, A, comma B, comma C, followed by a comma, and then say that the separator character is a comma, and then close the round brackets. The red squigglies are indicating that this function name doesn't yet exist, and again it's simply because the IntelliSense hasn't refreshed. You could head to Edit, IntelliSense, Refresh Local Cache, just to update the IntelliSense and then just get a bit of reassurance that it's going to run. So having done that, I can hit execute, and we will see that the results of that function are indeed a list of separate values using my single separator character. So now that we've established that our function is working, we can replace our string split function in our store procedure by calling on this new split string function. So we can copy split string, head back to the script which we're using to alter our procedure, and then find where we've got the string split function and replace that with our inventively named split string function instead. The parameter list is still the same, so we're passing in a long string, searching for a single character which separates the individual entries. So I can execute this entire script to update my store procedure, then head back to Report Builder and let's run the report. Let's start by selecting a single genre first and then click View Report. Check that works, it certainly does. Let's select a couple of different genres and then view the report again. That's certainly working. So if we just select all the genres, we should find that that works equally well as our built-in native SQL Server 2016 string split function. So at this point, adding more parameters to the store procedure is pretty easy. Let's head back to SQL Server Management Studio. I'll just hit Ctrl+R to hide my results panel. And let's add in a new parameter to accept a list of country IDs. So I'm going to add a new parameter. I'll call this one at country IDs. And it's going to be an nvarchar, and I'll make it 255 in length again. So Having done that, I now want to create or add to my where clause to check where the film country ID is in a list of the individual entries returned from my split string function. So probably the simplest thing to do here is just copy that entire condition from the where clause, stick the and keyword in there somewhere, and then paste in what we've just copied. So I'm going to check where the film country ID is in the list of values returned from our split string function, but referring to the country IDs parameter. Okay, so having done that, we can execute this procedure or execute this script to update the procedure. Then we can head back to our report builder report and head back to the design view. We should then be able to go to the film's dataset properties and just hit the refresh fields button to make sure everything's been updated and click OK. And that will force our parameter to be created. I'm just going to double click on the parameter and change its data type to an integer and allow multiple values. We'll deal with populating the available values shortly, but just for now, if I run the report, I'll select all the genres, and then for the country IDs, I'll just type in a couple. I'll type in 240, which is for the UK, and 241, which is for the United States. And if I click View Report, everything should just work exactly as we would expect. So if I get to the end of the list, I'll find the United States films in there as well. The final thing I'd like to do is populate the available values of this parameter so that we don't have to guess what the ID numbers of the countries are. Let's head back to the design view and start by creating a basic data set to select the list of countries and country IDs from the country table. So I'll right click on movies and choose add dataset, and I'll change the name of that dataset to country list. And then I'll use the query designer to quickly pick from my tables folder, and then from the country table, the country ID and the country. Having done that, I can click OK and then OK again. I can then go to the properties of my country IDs parameter, choose available values, get values from a query, and then set the dataset to country list, the value field to country ID, and the label field to country. Click OK and then run the report, and I'll see that I can now, let's just select all the genres quickly, and then from the country IDs list, I can select from the countries in my list. One minor problem with populating my country drop-down list as I have is that I've selected every single country from the country table, regardless if there are any films in my database made in that country. So my country table is just populated. I think I just copied a table from Wikipedia for all the countries in the world. So if I scroll further down this list, you'll see a huge number of countries which have no matching entries in my database, in my film table. So I'm going to modify that dataset to return only the countries in which films have been made. So let's head back to the design view, and I'm going to find my country list dataset, right click on it and choose dataset properties. I'll go to the query designer first, and then a simple way to restrict the list of countries to only those which have been used in the film table is just to include any column from the film table in the query designer. So I'll just go for film ID and then click OK, and that will update the from clause to join in the film table. I could then just delete the film ID column. I don't need that to be displayed anywhere. So that will limit the list to countries which appear in the film table. I'll also add an order by clause here as well, so I can order by the country column. So I'll say country, click OK, and then when I run the report, my country ID list will indeed be filtered to only those countries in which films have been made. But you can see another problem now is that I've got duplicates for each country. So I'm seeing one row for every film in the film table rather than for each unique or distinct country. So one final change to make back in the design view. I'll go back to the dataset properties of the country list. At the end of the select keyword, I can add the word distinct to select just the unique country IDs and country names, so that when I click OK, run the report again, I'll select just a couple of different genres, and then from the country IDs list is now nice and short and populated only with those countries in which films have actually been made. So there we go, that's how you deal with multi-value parameters when they're passed to stored procedures. Quite a lot of SQL involved there rather than report design, but hope you found it useful anyway. Thanks for watching, see you next time.